LRU cache. Let me change this to Swift. Oh, nice. It's already there. Alright. Design a data structure that follows the constraints of the least recently used LRU cache. Implement the LRU cache. LRU cache. Sorry, 1 minute. LRU cache. Int capacity, initialize LRU cache with positive slash capacity. Int get and key, return the value of the key if the key exists, otherwise return -1. Void, put in key value. Put the value of the key if the key exists, otherwise the key, add the key value paired to the cache. When the number of keys exceed the capacity from this operation, affect the least recently used key. Functions get input must run in O1 average time complexity. Okay, well, okay. Class LRU cache. I'm just running out some boilerplate code. And I'm just going to set this up. So we need an initializer. We need a variable. We need this variable should be int, and we need to set capacity, supply capacity equal to capacity, and then we want 3 different functions. I see get put. Oh no, just get input. So for get, we need a key that should be an integer, and we want to return the value of the key if the key exists, otherwise return -1, and return the value of the key. What's the value? Oh, it's an int as well. Okay, I saw here, and then put. I feel like I'm messing up somewhere. I think there should be func. Yeah, func. Put. We want both the key integer and we want the value integer there. We have all that information. We update the value of the key, otherwise add the key value paired to the cache. Okay, and evict the recently used key. And both of these should be 1, return the value of the key. Okay, so I've done this before. I apologize for my little, what do you call it, gurgle? Little, what do you call that? I don't know. Okay, so we have get. We want to return the value of the key if the key exists. How are we storing this? Right? Like, what is? Oh, I'm seeing key and value, so like I'm seeing some kind of a collection, right? And this collection. Just an int to an int, and then self dot collection set it to an empty, right? Okay, and then return the value of the key if the key exists, otherwise return -1. If how do I write this? If collection key equal nil, we just return -1. Otherwise, we can. What should we do? Guard let value equals collection key, else just return -1. And then we can just return value. So am I missing something? Why is this so... Initialize with a positive side capacity, yeah, okay. Evict the least recently used key. Sure. Hold on, let me why am I coding without actually like going through like an example? Alright, so like imagine we called this class. Okay. Cache, doesn't matter if it's that won't compile in Swift. Let's just pseudocode, you know. We have this, and then we want to cache that. We need a capacity. Let's set the capacity to 10, or maybe 5 for now. Not 105. Cache get 1. This should return -1. Cache dot put 1. Oh, yeah, I'm getting it, I think. So 1. Then we want nothing, but like now just in the dictionary, there's going to be something like this. And now if you do cache.get 1, you'll get like an answer of 1. Now cache put. So an important kind of thing to kind of keep in mind is that when we run this, okay, let's add a second element. Let's see. 2. 2. Okay. And cache dot get 2. 2. Okay. And then let me also just kind of keep track of this dictionary right here. Now the interesting part happens when we do this. Can we delete from this? Oh, number of keys exceeds. Okay, so let's make this a 3 then, just to make it a bit easier. Cache.get. Okay. What if we do 1? What happens? What happens is that now this is more recently used, and 2 and 2 is more least recently used. So least recently used, most recently used. So I'll just kind of leave it like that. And somehow we need to keep track of that. So in cache, put 3, right? And now this should be 3 like this, right? Keeping a track. And now if we do one more, 4, right? And now this should remove this and bring this 4. You see what I mean? So this get is not complete. I was going way too fast. Okay. do we keep track? And the thing is, we want to have this no one-time complexity, right? If I didn't know that, how would I would I just have kept on going with my way? I guess so. Keeping track of the least recently used. We want to be able to freely move these data structures around. Sorry, want to freely move the elements in these data structures. We want to keep track of that. How can we do that? What if we have a bit tough? So what I'm thinking, okay, so let me try, like what I'm kind of understanding from this least recently used pattern is that the front is being kind of, or I don't know which, the front or the back or where it is, but we need the ability to move around the elements. Like you saw this one, let's just take it out from here and put over here, right? If you do that in the middle of an array, if you take it out from here and put it at the beginning, well, that could be worst case like O of n, n being the number of elements in an array, right? Because you're removing it, and arrays, like if you remove from the front, then you have to shift all the elements from the front. If you remove from the middle, you have to shift half the elements, which is almost like it's still linear time. So instead of an array, not even like a queue, or like queues are like first in, first out, so like you can remove it from the beginning, whereas arrays you couldn't do that. But then how are queues implemented? They're actually implemented using linked list, and linked list might be the way to go here because like look, you have 2, 1, 1, 3, right? Like kind of representing this over here. Let me just like copy paste this here. And now you want to remove 1 and put it here. 1, 2, or sorry. Hold on. We have 1 here. Imagine we have this, okay? We're at this state here. That we call what do we do? Sorry, hold on. I'm messing up my example. We're at this stage here. We're going to call cache.get 1. What this does, it switches it to here. And switches the 1. No, I copied that wrong. Let me just 1 like that. Okay. So we have to take it out from the middle. And put it here. 1. Now what do we need to actually be able to do this? First of all, 2 points to 3. Okay? Now from 1, because that's what we have from get, right? We have 1. How can we know the next value for 3, but we don't know what it is for 2. So this is where, instead of just using a single linked list, why don't we just make a double? This way, we know 1, we know the previous value, and we know the next value. We can set the previous on next equal to 1.x, which is 3, and then just set this to the end, to the most recently used section. And I'm pretty sure that should work. Let me try and implement that. This way it would be 1 time. It doesn't say anything about space complexity, so I'm going to leverage that to my advantage. So guard, return value. Now in collections. So how do I, so this double linked list, where do I store this? Okay, so I have done this before, and I remember that this was actually like something like this in a node, right? And then now, what does this node represent? It represents this. Let me just call it. We know it's a double linked list. We know this is a node, so we want a few things. We want val to be 0, we want previous to be nil, we want next to be nil, and I should probably have set this and set this to an optional node, and set this to a optional node as well, and then we'll do var val int var previous node var next node self dot val self dot previous self dot next. Okay, so that's the node we're capturing here. And then with this node, we know we have a reference to previous, we have a next reference to next. So we can, first of all, int value 0. That's what we want to return. Node value, and then we can do node.previous is equal to node.next. Okay, so that's that. And then before that, do we want to do this node.val? we have to set this node somewhere. How do I know what's the most recently used? 1. Because sure, I've done this now, right? I've attached 2 and 3. How do I attach 1 to all the way at the end? I feel like this is a simple thing and I just can't see it right now. So we did this, got rid of no, this is not right. This is not right. You want to do something like this, node.next. Do the node.next like that, right? Assuming there is a previous, assuming there is a node.next. And then do we need like a reference to the end, like var tail node? So whenever this is done, input, we set the tail to be like a certain node, right? And then we set tail.x is equal to node, and then we do all the stuff. First thing first. First thing first, let me set this as like that. This should, this should just be node. And then here, tail should be like that. Previous should also be like that. Node. Node value. Hold on, let me change this wording. I don't like this wording. Okay, and node can be this. So we can have this, we can have this, or we can have this. Optionals there. Okay, and then coming here to put. So when you put something, right, you have cache dot put 4, right? And then you have to check first of all if capacity has been reached. So check if capacity has been reached. Need to, if so, need to remove LRU position element. Regardless, append to end of tail as MRU, like most recently used. So here, do we need a capacity check? I think we do. So let's do so that size is 0, and then eventually we want to do self.size plus equals 1. And then here we want to do self.capacity is if self-capacity self.size is greater than self.capacity, then we want to do kind of this code. And then do we need a reference to the beginning as well? How do we move from this position? Huh. So we need a head as well. Self.head is equal to node, and then self.tail should be equal to head. Okay. So delete. From the head. Let node to delete is equal to head. Head is equal to head dot x. And we want to be using like self.head, right? Self.head, self.head, and tail. Should tail change? Not really, unless, I mean, if it's the first time, then this is going to cause some problems. How do I consider the tail condition? Tail condition, especially if size of double lengthness was 1. So just making a note of that so I don't forget. So after we do this, we also want to delete it from the collection. So delete collection. Node to delete dot val. Okay. And that should delete it from the collection. Okay. Okay. Now, regardless of size, I don't think we need this. Append at the end of tail. Tail.x. Append. So this particular node is actually going to be a bit different. It's not going to hold, it's going to hold a key add value. So many different details to this question. Wow. Okay. And then key is equal to key. I could have just kept it as value, to be honest. So that value is equal to value, but whatever, it's fine. Did I use .val anywhere? I used it here, so let me pull up the key like that. And then tail.next, we're gonna need the node. Key value. Just do this. Okay, 0, 0. And here, let me do key value. And tail. Previous would be tail. So we have to keep note of that. Tail is equal to tail.next. Self is equal to self.size plus equal to 1. That doesn't feel complete. I feel like I'm definitely missing this scenario. Summation capacity is just 1. I can't set tail on next to be, I can't set like over here tail to be head.next because head.next is just nil, and then tail doesn't really have a reference, it's just nil. I'm missing some stuff. There's definitely some. I just remember the answer being a lot more detailed. Like there was insertion, removal, and I am convoluting all of that. Should I try running it through this like kind of test case I got going? And then I'm just trying to go through the steps that I should be going through. I mean, the time complexity is already given here. Space complexity I didn't really talk about, to be honest. But we have a linear, at least a linear space complexity, linear to the number of queries. Queries of specifically put, because that's the one actually putting into the collections. And then we have this other linear kind of linked list that's being created. So 2n, which ends up just simplifying to being a linear memory space. Alright, so we have this. We did LRU cache 3. Set capacity to 3. Beautiful. I don't know if size should be 0 or 1. Don't know. We're adding an extra node here. Yeah. That's not good. That's an edge case as well. Like, how do I... So if I'm always going to add to the left of this node, it's just basically a filler node that's being added. How do we deal with this? That's going to cause us some problems. Alright, let's walk through this. So cache.get garlet value collection key. Else return -1. So it's going to return -1. Just a simple kind of case because collection is just empty right now. Then we got to put. So put 1 if self.size is greater than self.capacity. This is 0. This is 3. This is wrong. We come here to next. We set up a new node. Node is equal to key value 2. I'm going to do this actually. If self.size is equal to 0, this is the first time this is happening. And this is going to be specific. And then this is going to be like this. I'm seeing a lot of this. Like I'm saying the word this a lot. Here, what I want is the following. Previous and nil should not be anything. It should be nil. Tail should not be the tail on X or anything, but this should be on the outside. Like that. So if on the first time, head and tail are equal to node key value. Cool? Alright, and then we get... Did we add to the dictionary? We did not, did we? Let's add to the dictionary. There's going to be a lot of repeated code now that I think about it. Key value and default default 0 plus equals value. Same thing here. What if the same key appears again and again? Can you have duplicate keys? Clarifying question. Good one to ask. I don't know. I think it can. Hold on, did I read this up to the value of the key if a key exists? Otherwise the key add the key value grades the cache. Okay. Alright. So we didn't consider that scenario. So if we update the value, then we also want to bring it to the most recently used. So let me get rid of this. Let me just do that. Let me equal this. Get rid of this. For both of these calls, oh, I got distracted. My bad. I was listening to a conversation outside. Eavesdropping. Where was I? We do this. This is either overwriting or not. So you gotta do a check. If it's overwriting, then you gotta do like a whole node thing. Yeah, I don't like the way I'm doing this. It's getting pretty messy. I'm at 40 minutes. I'm gonna stop here. I'm gonna watch the solution. It's good that I attempted this though. All right, let me watch the solution.